Hello children, we are starting chemistry today and the topic is some basic concepts of chemistry. If someone asks you to define chemistry, you may say in a simple sentence, chemistry is the science of atoms and molecules, and that is correct. However, a more polished definition is a branch of science that studies preparation, properties, structure and reactions of material substances is called chemistry. Here the keyword is material substances. So most of the time we will talk about material substances. Now we will talk about matter and material substances. So the question is, what is matter? Anything that has mass and occupies space is called matter. For example, pen, pencil, table, chair, this board, this wall, this camera, you and me, everything is matter. There are three states of matter: solid, liquid and gas. And their detailed properties we have already studied in previous classes. If you need a refresh, you can go through my class 9 chapter 1 video, that is matter in our surroundings. Link is given in the description box below. Matter can be classified into two categories based on its physical properties and chemical properties. Physical properties such as color, odor, density, melting point, boiling point, etc. And chemical properties such as chemical composition, combustibility, reactivity with acids, bases, etc. Based on physical properties, it can be further classified into solid, liquid and gas. And based on chemical properties, it can be further classified into pure substances and mixtures. In pure substances, all the constituent particles exhibit the same composition. It can be further classified into elements and compounds. In elements, all the particles are of same type and they show the same nature. For example, carbon, hydrogen, oxygen, nitrogen, etc. When two or more elements combine in a definite ratio, they make compound. For example, H2O, water molecule, in which hydrogen and oxygen gases combine in 2:1 ratio by volume to form a water molecule. Mixtures. When two or more pure substances combine in any ratio, they form the mixture. In any mixture, these pure substances are called as its components. Mixtures can be further classified into homogeneous mixture and heterogeneous mixture. In homogeneous mixture, these pure substances means these components completely mix with each other so that the constituent particles exhibit the same composition throughout the mixture. For example, air, sugar solution, salt solution, etc. If that is not the case, the mixture is called as heterogeneous mixture. For example, grains and pulses are mixed together and they have some dirt particles and stones, etc. Another example can be when you mix sugar and salt. Physical properties can be measured or observed without changing the identity or composition of the substance. On the other hand, to measure or observe chemical properties, a chemical change is required. Now let us see laws of chemical combinations. There are 6 laws. We will see them one by one. First one is law of conservation of mass. It was given by Antoine Lavoisier in 1789. As per this law, matter can neither be created nor destroyed. There is no net change in mass during the physical or chemical change. And in a chemical reaction, total mass of the reactants is equal to total mass of the products. Let us see one question based on this. 10 grams of calcium carbonate when heated produces 3.8 grams of carbon dioxide and 6.2 grams of calcium oxide. Show that the result is in line with the law of conservation of mass. So the chemical reaction will be something like this. CaCO3 when heated will give CaO plus CO2. Now it is given that mass of CaCO3 is 10 grams. So write 10 grams here. Produces 3.8 gram of carbon dioxide. 3.8 gram right here. And 6.2 grams of calcium oxide. 6.2 grams of calcium oxide. So as per this law, total mass of the reactant must be equal to total mass of the products. So let us add 6.2 and 3.8. 6.2 and 3.8 will give 2 plus 8, 10. 0, carry over 1. 1 plus 6, 7 plus 3, 10. Means total mass of the reactant is equal to total mass of the products. So the result is in line with the law of conservation of mass. Second one is law of reciprocal proportions. It is also known as law of equivalent weight. It was given by Richter in 1792. So let us understand what is this. The ratio of weights of two elements A and B which combine separately with a fixed weight of the third element C is either the same or some simple multiple of the ratio of the weights in which A and B combine directly with each other. This sounds complicated. However, it will look simple when we take this example. Suppose my element A is carbon, B is oxygen and C is hydrogen. Atomic mass of carbon is 12, hydrogen is 1 and oxygen is 16. When carbon and hydrogen combine, they make CH4. When oxygen and hydrogen combine, they make H2O as per this reaction. So let us calculate the ratio of their masses when they combine. So ratio of carbon and hydrogen when they make CH4 will be C is to H will be equal to 12 divided by 1 into 4 means 12 divided by 4. So 12 is to 4. Ratio of oxygen and hydrogen when they combine. So it will be 32 is to 4. So ratio of oxygen is to hydrogen will be 32 is to 4. Now we have to fix the mass of hydrogen with which carbon and oxygen combine. It is already fixed. So let us say it is 4 gram. So with 4 gram of hydrogen, 12 gram of carbon is combining. With 4 gram of hydrogen, 32 gram of oxygen is combining. So ratio of carbon is to oxygen when they combine should be 12 is to 32. 12 is to 32 or a simple multiple of it. So let us verify when carbon and oxygen combine together. So ratio of C is to O. From here it should be 12 divided by 16 into 2 means 32. So 12 is to 32. You see the ratio of their masses is same as this, or it could have been a multiple of 12 is to 32. Means law of reciprocal proportion holds true. Third one is law of definite proportions. It was given by Joseph Proust in 1797. As per this law, a given compound always contains exactly the same proportion of elements by weight. This law is also called as the law of definite composition. In a water molecule, the ratio of hydrogen and oxygen will always remain 1 is to 8 by weight, whether it is tap water, river water or sea water. Fourth one is law of multiple proportions. It was given by Dalton in 1803. So let us understand this law. If two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. So we will understand this more clearly with the help of this example. Suppose hydrogen and oxygen combine to make two compounds, water and hydrogen peroxide. When they form water, the chemical reaction will be like this. 2H2 plus O2 makes 2H2O, and when they make hydrogen peroxide, the chemical reaction will be like H2 plus O2 makes H2O2. Ratio of hydrogen and oxygen in water will be 4 is to 32, and ratio of hydrogen and oxygen in H2O2 will be 2 is to 32. Now fix the mass of oxygen in both the compounds. That is already fixed here. So ratio of hydrogen will be 4 is to 2 in two compounds, that is 2 is to 1, which is a simple ratio. Fifth one is Gay-Lussac's law of gaseous volumes. It was given by Gay-Lussac in 1808. So let us see this law. When gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. Suppose two gases, hydrogen and oxygen, combine to make water vapor. Two volumes of hydrogen will combine with 1 volume of oxygen to make 2 volumes of water vapor. That means 100 ml of hydrogen will combine with 50 ml of oxygen to make 100 ml of water vapor. So the ratio of hydrogen and oxygen will be 100:50, means 2:1, which is a simple ratio. Last one is Avogadro's law. It was given by Avogadro in 1811. So let us see the law. Equal volumes of all gases at the same temperature and pressure contain equal number of molecules. We will see its application going ahead. Let us see Dalton's atomic theory, which he had given in 1808. It was a 4-pointer theory. Point number 1, matter consists of indivisible atoms. Point number 2, all atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Third point, compounds are formed when atoms of different elements combine in a fixed ratio. And the fourth point, chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reactions. There were some drawbacks in Dalton's atomic theory. We will discuss them point by point. First point, he said, matter consists of indivisible atoms. With the discovery of subatomic particles like electron, proton and neutron, it was clear that atoms are no longer indivisible. Second point, he said, all atoms of a given element have identical properties, including identical mass. With the discovery of isotopes, it was clear that all atoms of a given element may not have equal mass. They may differ in mass. Third point, he said, compounds are formed when atoms of different elements combine in a fixed ratio. He could not provide the reason why atoms combine. And the fourth point, he could not explain the law of gaseous volumes. There are many subatomic particles. Among them, 3 are main: electron, proton and neutron. Electron is represented by small e or small e minus, minus sign written as superscript. Proton is represented by small p and neutron is represented by small n. This table shows their symbol, mass and charge. Electron is represented by small e. Its mass is 9.1 into 10 to the power minus 31 kg and its charge is minus 1.6 into 10 to the power minus 19 coulomb. Proton is represented by small p. Its mass is 1.67262 into 10 to the power minus 27 kg and its charge is exactly the same that of electron with opposite sign, means 1.6 into 10 to the power minus 19 coulomb. Neutron's mass is 1.67493 into 10 to the power minus 27 kg and it is neutral, so its charge is 0. You may notice that heaviest is neutron. Neutron is slightly heavier than proton and lightest is electron. Other subatomic particles are positron, antiproton, neutrino, meson, etc. Now we will see atomic number and atomic mass. Atomic number first. The number of protons present in the nucleus is known as atomic number of the element. It is represented by capital Z. It is also known as nuclear charge. So Z is equal to number of protons. How to calculate the number of electrons? For neutral atom, number of electrons is equal to number of protons is equal to capital Z. And for charged atom, number of electrons is equal to Z minus charge on atom. We will see couple of numericals based on it. Atomic mass or mass number. The sum of number of protons and neutrons is known as atomic mass of the element. It is represented by capital A. It is also known as number of nucleons, as protons and neutrons are present in nucleus. An atom of an element is represented by either this way or this way, where X represents chemical symbol of the element, Z is its atomic number and A is its atomic mass. For example, neutral atom will be written like 6C12, 8O16. Charged atom will be written like 11Na+, 13Al3+, or plus, 9F-. Let us see this question. If the number of protons in A2- is 14, then find the number of electrons in A2- and A2+. We know that number of protons is equal to Z. So Z is given as 14. We have to calculate the number of electrons in charged atoms. So number of electrons in A2 minus will be equal to Z minus charge an atom, that is minus 2. Z is given as 14, so 14 minus minus 2. Minus into minus is equal to plus. So it will be 14 plus 2 and that is equal to 16. Similarly, number of electrons in A2 plus will be equal to Z minus charge an atom, that will be plus 2. Z is 14, so 14 minus 2 will be equal to 12. There is a quicker method. Suppose A is not charged atom, this is neutral atom. So number of protons will be equal to number of electrons, means 14 electrons. But A2 minus is negatively charged and it is having 2 surplus electrons. So we will add 2 in 14. So 14 plus 2 means 16. In A2 minus, number of electrons is equal to 14 plus 2, 16. Similarly, in A2 plus, there is a shortage of 2 electrons, means 14 minus 2, that is equal to 12 electrons. See, the result is same. Second question, an element X with mass number 81 contains 31.7% more neutrons as compared to protons. Find the chemical symbol for X. It is given as mass number A is equal to 81. Suppose number of protons are X. Then number of neutrons will be equal to X plus 31.7%, means 31.7 upon 100 times X. So take X as common, so it will be 1 plus 31.7 upon 100 and that will come out to be 1.317X. So when you add number of protons and neutrons, it will give as mass number. So A is equal to P plus N, means X plus 1.317X. So A is 81. So 81 will be equal to 2.317X. When you calculate X, X will be approximately 35. Precisely, it will be 34.9. And what is X? Number of protons. And number of protons is nothing but atomic number. So Z is equal to 35, approximately equal to 35. And that is element bromine. So X is bromine, Br. Now we will see isotopes, isobars and isoelectronic. First, isotopes. Atoms of same element which have the same atomic number but different atomic mass are called isotopes. Example, hydrogen has 3 isotopes, 1H1, 1H2 and 1H3. Notice Z is same but A is different. Similarly, carbon has 3 isotopes, 6C12, 6C13 and 6C14. Oxygen has 3 isotopes, A216, A217 and A218. Isobars. Elements that have the same number of nucleons are called isobars, means they have the same atomic mass. For example, 16S40, 17Cl40, 18Ar40, 19K40, 20Ca40. So you notice here they are different elements having the same mass number. So they are isobars. Isoelectronic. Atoms, molecules or ions having the same number of electrons are called isoelectronic. For example, Na plus, Mg2 plus, Al3 plus, O2 minus, F minus. So let us calculate the number of electrons in them. So atomic number of sodium is 11. So number of electrons will be 11 minus 1, means 10. Atomic number of magnesium is 12. So number of electrons it will have 12 minus 2, that is 10. Atomic number of aluminium is 13. So number of electrons it will have 13 minus 3, means 10. Atomic number of oxygen is 8. It has 2 surplus electrons, means 8 plus 2, 10 electrons. Atomic number of fluorine is 9. It has 1 surplus electron, means 9 plus 1 is 10. So you see, all have 10 electrons. So they all are isoelectronic. Isotones are isoneutronic. Atoms of different elements having same number of neutrons are called isotones are isoneutronic. You know that A is equal to P plus N, means number of protons plus number of neutrons, and Z is equal to P. So the difference of A and Z will give number of neutrons. See in this example, 6 is 13 and 7 and 14. Difference is 13 minus 6 is equal to 7 and 14 minus 7 is equal to 7. So they are isoneutronic. Similarly, 14 Si30, 15 P31 and 16 S32. See the difference of A and P is 13 minus 14 means 16. 31 minus 15 means 16. 32 minus 16 is equal to 16. So they are isoneutronic. Isodiaphers, atoms of different elements which have the same difference between the number of neutrons and the number of protons. That is, n minus p or p minus n should be same. For example, 7 and 15 and 9f19. So let us calculate the number of protons and number of neutrons. So number of protons it has is 7. So P is 7. Number of neutrons can be calculated from here. So difference of A and Z. So difference of A and Z is 15 minus 7. That is 8. So number of neutrons it has is 8. In this case, number of protons is equal to 9 and number of neutrons is difference between these. So 19 minus 9, that is 10. Now calculate difference between P and N, that is 8 minus 7, 1, and in this case 10 minus 9, that is 1. So they are isodiaphers. Similarly, 5B11 and 6C13. So number of protons here is 5. Number of neutrons is difference between 11 and 5, that is 6. And in this case, number of protons is 6 and number of neutrons is difference between 13 and 6, that is 7. Now calculate P minus N or N minus P. So that is 6 minus 5, that is 1, and in this case 7 minus 6, that is 1. So they are isodiaphers. Isosters, molecules which have the same number of atoms and electrons are called isosters. For example, CO2 and N2O. We will verify number of atoms first. CO2 has 3 atoms, 1 atom of carbon and 2 atoms of oxygen. N2O has 3 atoms, 2 atoms of nitrogen and 1 atom of oxygen. So they have same number of atoms. Now let us calculate the number of electrons. Atomic numbers of these elements are written here. So number of electrons in CO2 means 6 into 1 plus 8 into 2 means 6 plus 16, that is 22. Number of electrons in N2O will be, atomic number of nitrogen is 7. So 7 into 2 plus 8 into 1. So it will be 14 plus 8 means 22. So they have same number of electrons as well. So CO2 and N2O will be called as isosters. Similarly, CaO and KF are isosters. So let us see number of atoms first. CaO has 2 atoms, 1 atom of calcium and 1 atom of oxygen. KF has 2 atoms, 1 atom of potassium and 1 atom of fluorine. Number of electrons in CaO, Ca has 20 electrons and oxygen has 8 electrons. So 20 into 1 plus 8 into 1, that is 28. In KF, atomic number of K is 19. So 19 into 1 plus atomic number of fluorine is 9. 9 into 1. So it will be 19 plus 9, that is 28. So they have same number of electrons as well. So CaO and KF are isosters. Now let us see the mole concept. Atoms and molecules are extremely small in size. Their numbers in even a small amount of substance is very, very large. To handle such large numbers, a unit of convenient magnitude was required. In SI, mole was introduced as the 7th base quantity for the amount of a substance. 1 mole contains exactly 6.022140076 into 10 to power 23 elementary entities. An elementary entity may be an atom, a molecule, an ion, an electron, any other particle, or a specified group of particles. 1 mole of a substance always contains the same number of entities. 1 mole is a collection of 6.023 into 10 to power 23 entities. This statement is important, you need to keep in mind. Also, these statements are important. 1 mole of an atom is also known as 1 gram atom. 1 mole of ions is also known as 1 gram ion. And 1 mole of molecules is also known as 1 gram molecule. Now let us see how to calculate number of moles. If number of any entity is given, then number of moles is equal to number of entity upon Na. Na is Avogadro constant. Its value is 6.023 into 10 to power 23 per mole. If mass of an entity is given, suppose mass of atoms is given, then number of moles is equal to mass of entity upon atomic mass. If mass of molecules is given, then number of moles is equal to mass of entity upon molecular mass. In case of gases, number of moles is equal to PV upon RT, where R is 0.0821 liter atmospheric per mole per Kelvin. 1 mole of any gas at STP occupies 22.4 liter volume or space. Now let us see relative atomic mass. Relative atomic mass of an element was first defined with respect to one hydrogen atom, then with respect to one oxygen atom, and finally with respect to one carbon-12 atom. So relative atomic mass of an element with respect to one hydrogen atom is equal to mass of one atom of an element divided by mass of one hydrogen atom. And relative atomic mass of an element with respect to one oxygen atom is equal to mass of one atom of an element divided by 1 by 16 of mass of one oxygen atom. And relative atomic mass of an element with respect to one carbon-12 atom is equal to mass of one atom of an element divided by 1 by 12 of mass of one carbon-12 atom. Unit of relative atomic mass is AMU or U. AMU stands for atomic mass unit and U stands for unified mass. Now let us see gram atomic mass and gram molecular mass. First, gram atomic mass. The atomic mass of any element expressed in gram is called its gram atomic mass. It is also defined as mass of 6.023 into 10 to power 23 atoms. For example, gram atomic mass of magnesium is 24.305 U. So mass of one atom of magnesium will be equal to 24.305 divided by Avogadro constant, means 6.023 into 10 to power 23. So the result will be 4.035 into 10 to power minus 23 gram. It means mass of one atom of magnesium will be 4.035 into 10 to power minus 23 gram. Gram molecular mass. The molecular mass of an element expressed in gram is called its gram molecular mass. It is also defined as mass of 6.023 into 10 to power 23 molecules. For example, gram molecular mass of oxygen is 32 U. So mass of one molecule of oxygen is equal to 32 upon 6.023 into 10 to power 23. It is equal to 5.313 into 10 to power minus 23 gram. It means mass of one molecule of oxygen is equal to 5.313 into 10 to power minus 23 gram. Percentage composition and molecular formula. We will see two terms, average atomic mass and mean molar mass. Average atomic mass is also known as mean atomic mass. The weighted average of the atomic mass of all isotopes is called average atomic mass or mean atomic mass. So formula is A average is equal to A1x1 plus A2x2 plus A3x3 up to ANxn divided by 100, where A1, A2, A3 up to AN are atomic masses of the isotopes and x1, x2, x3 up to xn are mole percentage of isotopes. We will see numericals based on it. Second one is molecular mass or mean molar mass. Mean molar mass of the compound is given by the formula N1M1 plus N2M2 plus and so on up to NNMN upon N1 plus N2 plus N3 up to Nn, where M1, M2, M3 up to Mn are molar masses of the elements and N1, N2, N3 up to Nn are number of moles. Next we will see some numericals based on these formulas. Now let us see some questions. First question, calculate the sum of the number of electrons, protons and neutrons in 16 gram of A216. First we will calculate the number of moles. Number of moles is given as given mass of the substance upon atomic mass of the substance. Given mass of the substance is 16 gram and atomic mass of the substance is 16. So 16 upon 16, that is number of moles is 1. Number of electrons is equal to number of moles into Avogadro constant into number of electrons. Number of electrons here are 8. So it will be multiplied by 8. Number of protons is equal to number of moles into Avogadro constant into number of protons. Number of protons are 8. And number of neutrons is equal to number of moles into Avogadro constant into number of neutrons. 16 minus 8 means 8. So total will be sum of all three. So that will be equal to 8 plus 8 plus 8 means 24 into Avogadro constant. So that will be equal to 24 into 6.023 into 10 to power 23. And that will come out to be 1.44552 into 10 to power 25. Second question, the group having isoelectronic species is. These are the options given. We have to find out in which option all have same number of electrons. I have written their atomic numbers here. So let us start. In option A, O minus will have 8 plus 1 means 9 electrons. F minus will have 9 plus 1 means 10 electrons. Since they have different number of electrons, so this option is wrong. Let us see option B. O2 minus means 8 plus 2 means 10 electrons. F minus will have 9 plus 1 means 10 electrons. Na plus will have 11 minus 1 means 10 electrons. Mg2 plus will have 12 minus 2 means 10 electrons. So this option is correct. If there are more than one correct options, then you need to investigate further, otherwise you may stop here. Third question, the amount of oxygen in 3.6 moles of water is. These are the options given. First we need to calculate the mass of 1 mole of water. So let us calculate. And that will be equal to 2 into atomic mass of hydrogen, that is 1, plus 1 into atomic mass of oxygen, that is 16. And that is equal to 2 plus 16 means 18 gram. Out of 18 gram, 16 gram is oxygen. Means in 1 mole of water, there is 16 gram of oxygen. So in 3.6 moles of water, how much oxygen? So let us write, in 1 mole of water, there is 16 gram of oxygen. So in 3.6 moles of water, how much oxygen? That will be 3.6 into 16 gram. So that will come out to be 16 6 are 96. 9 carry over. 16 3 are 48 plus 9. That is 57. So in 3.6 moles of water, there is 57.6 gram of oxygen. So let us see which option is correct. Option D is correct. Fourth question, given that the abundance of the isotopes 54Fe, 56Fe, 57Fe are 5%, 90% and 5% respectively, the atomic mass of the iron is. These are the options given. To calculate the average atomic mass of iron, we need to multiply their atomic mass with abundance. So it will be 54 into 5 by 100 plus 56 into 90 by 100 plus 57 into 5 by 100. And the answer will come out to be 55.95 U. So the correct option is Option B. Fifth question, hydrogen has three isotopes A, B and C. If the number of neutrons in A, B and C respectively are X, Y and Z, the sum of X, Y and Z is. These are the options given. We know that hydrogen has three isotopes, 1H1, 1H2 and 1H3. We need to calculate the number of neutrons in them and then add them. Number of neutrons can be calculated by A minus Z. So in 1H1, number of neutrons will be 1 minus 1 means 0 plus. In 1H2, number of neutrons will be 2 minus 1 means 1. In 1H3, number of neutrons will be 3 minus 1 means 2. So the summation will be 3 and the correct option will be B. Sixth question, the average molar mass of the chlorine is 35.5 gram per mole. The ratio of 35Cl to 37Cl in naturally occurring chlorine is close to. These are the options given. Suppose there are N1 moles of 35Cl and N2 moles of 37Cl. Then average molar mass will be given by 35.5 is equal to N1 moles of 35 means N1 into 35 plus N2 moles of 37Cl means N2 into 37 divided by N1 plus N2. Now cross multiply, you will get 35.5 N1 plus N2 is equal to 35 N1 plus 37 N2. Now 35.5 N1 minus 35 N1 will be equal to 0.5 N1 is equal to 37 N2 minus 35.5 N2 will be equal to 1.5 N2. So N1 by N2 will be equal to 1.5 upon 0.5 and that will be equal to 3:1. So the correct option is option D. Last question, complete combustion of 1.80 gram of an oxygen containing compound CxHyOZ gave 2.64 gram of CO2 and 1.08 gram of H2O. The percent of oxygen in the organic compound is. These are the options given. So the chemical reaction will be something like this. CxHyOZ plus O2 makes CO2 plus H2O. We will try to balance hydrogen and carbon. On the right side, there are two hydrogen atoms. On the left side, there are Y hydrogen atoms. So on the right side, we will multiply by Y and on the left side by 2. So hydrogen atoms on both the sides will be 2 into Y means 2Y. On the right side, there is one carbon atom and on the left side, there are 2x carbon atoms. So on the right side, we have to multiply by 2x here. So on the both sides, there are 2x carbon atoms. Oxygen atoms are not balanced. We will start our calculation from here. Mass of CO2 will be 44. 12 plus 16 into 2. So 2x multiplied by 44 is 2.64 which is given in the question. So x is equal to 2.64 upon 88. Similarly, mass of water is 18. 2 into 1 plus 16. 18 into Y is 1.08 gram which is given in the question. So Y is 1.08 upon 18. On the left hand side, mass of this is given as 1.8 gram means 2 times of mass of this. Mass of this can be calculated as x into 12 plus y into 1 plus z into 16 and that total is 1.8. So z can be calculated by substituting the values of x and y from here. Z will come out to be 0.03. Now mass of this whole is 1.8. So mass of this is 1.8 divided by 2 means 0.9 gram. So out of 0.9 gram, mass of oxygen is 16 into Z means 16 into 0.03 that is 0.48 gram. So out of 0.9 gram of CxHyOZ, oxygen is 0.48 gram. So out of 100 how much? It will come out to be 53.33. So option C is correct. Let us understand empirical and molecular formula of a compound. Empirical formula represents simplest whole number ratio of various atoms present in a compound, whereas molecular formula represents the exact number of various atoms present in a molecule of a compound. Suppose in an experiment it is found that carbon, hydrogen and oxygen react in 1:2:1 ratio by weight to form a compound. Then empirical formula of the compound will be given by CH2 and the molecular formula of the compound will be given by C6H12O6. Means in a molecule of glucose there are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. Quite clearly the common multiplier is 6. Common multiplier N is given by molecular weight of the compound upon empirical formula weight of the compound. Let us solve one numerical based on it. A compound contains 24.27% carbon, 4.07% hydrogen and 71.66% chlorine. Its molar mass is 98.96 gram. What are its empirical and molecular formulas? Suppose mass of compound is 100 gram. So mass of carbon is 24.27 gram. Mass of hydrogen is 4.07 gram and mass of chlorine is 71.66 gram. Now we will calculate the number of moles of carbon, hydrogen and chlorine. Number of moles of carbon is equal to mass of carbon upon atomic mass of carbon. That comes out to be 2.021. Number of moles of hydrogen is equal to mass of hydrogen upon atomic mass of hydrogen. That comes out to be 4.04. Number of moles of chlorine is equal to mass of chlorine upon atomic mass of chlorine. That comes out to be 2.021. Now divide all three by the smallest number among them. So smallest is 2.021. When you divide all three, that comes out to be 1, 2 and 1 respectively. So ratio of carbon, hydrogen and chlorine by weight is 1:2:1. So empirical formula will be CH2Cl. Now let us calculate empirical formula mass. So it will be 12.01 into 1 plus 1.008 into 2 plus 35.453 into 1. That comes out to be 49.48 gram. It is given that molar mass is 98.96 gram. So common multiplier N will be molar mass upon empirical formula mass. That comes out to be 2. So molecular formula of the compound will be C2H4Cl2. Now let us see density. Density is of two types, absolute density and relative density. Absolute density is equal to mass of substance upon volume of the substance. And relative density, as the name suggests, it is with respect to some substance. So let us see. For solids and liquids, absolute density is equal to mass upon volume. And relative density, which is also known as specific gravity, is equal to density of the substance upon density of water at 4 degrees centigrade. And density of water at 4 degrees centigrade is 1 gram per ml. For gases, absolute density is equal to molar mass upon molar volume. Relative density, which is also known as vapor density. So vapor density is defined as the density of the gas with respect to hydrogen gas at the same temperature and pressure. It can be calculated with respect to other gas as well. Formula for vapor density is equal to density of gas upon density of hydrogen gas. Vapor density is equal to molecular weight of gas upon molecular weight of hydrogen gas, and this is 2. So molecular weight of gas is equal to 2 times of vapor density. Let us see a couple of numericals based on density. First question is, what is the density of oxygen gas relative to sulfur dioxide gas under the same temperature and pressure? Density of oxygen upon density of sulfur dioxide is equal to molecular weight of oxygen gas upon molecular weight of sulfur dioxide gas, and that is 16 into 2 upon 32 plus 16 into 2. That comes out to be 32 upon 64, that is 1/2, and that is equal to 0.5. Second question, calculate the vapor density of a gas if its density is 0.2 gram per liter at STP. We know that weight of 22.4 liter of a gas at STP is known as its molecular weight. So molecular weight of the gas is 22.4 into density, that is 0.2. That comes out to be 4.48 gram. So vapor density of the gas is defined as molecular weight of the gas upon molecular weight of hydrogen gas. So it will come out to be 4.48 upon 2, that is 2.24. Now let us see gravimetric analysis. It is a method of quantitative analysis in which desired constituent is converted into a substance of known composition that can be separated from the sample and weighed. For example, in a chemical reaction, if precipitate is formed, that can be separated from the sample and weighed. We will see four types of numericals based on gravimetric analysis, and they are mass-mass analysis, mass-volume analysis, mass-mole analysis, and volume-volume analysis. We will see one question on each. First one is mass-mass analysis. Question: an ore contains 2% of Ag2S by weight. How many grams of this ore has to be processed to get 1.5 gram of pure silver? Atomic mass of silver is 108 and that of sulfur is 32. First we will calculate molecular mass of Ag2S, and that is 108 into 2 plus 32, that is 248 gram. So out of 248 gram of Ag2S, silver is 216 gram. So we will form our logic here. 216 gram of Ag is present in 248 gram of Ag2S. So 1.5 gram of pure silver is present in how much of Ag2S? Second statement we will form from here. Since 2 gram of Ag2S is present in 100 gram of ore, as 2% of Ag2S is present in ore by weight, means 100 gram of ore contains 2 gram of Ag2S. So that's what it is written here. 2 gram of Ag2S is present in 100 gram of ore. So this much of Ag2S is present in what amount of ore? That comes out to be 86.11 gram of ore. Now let us see mass volume analysis. Question: how much calcium carbonate of 90% purity would be required to prepare 2.24 liter of carbon dioxide at STP when calcium carbonate reacts with dilute hydrochloric acid? The balanced chemical equation is given by CaCO3 plus 2HCl makes CaCl2 plus H2O plus CO2. It is clear from this equation that 1 mole of calcium carbonate produces 1 mole of carbon dioxide gas. Carbon dioxide gas that needs to be produced is 2.24 liter. We know that volume of 1 mole of any gas at STP is 22.4 liter. So number of moles in 2.24 liter of carbon dioxide will be 2.24 upon 22.4, that is 0.1 mole. So 0.1 mole of carbon dioxide will come from 0.1 mole of calcium carbonate. So mass of 0.1 mole of calcium carbonate will be 0.1 into molar mass of calcium carbonate. So it is 0.1 into 100, that is 10 gram. It is given that sample is 90% pure, means 90 gram of pure calcium carbonate comes from 100 gram of impure sample. So 10 gram of pure calcium carbonate will come from 10 into 100 upon 90 gram of impure sample. So that comes out to be 11.11 gram of impure sample, and that is the answer. Now let us see mass mole analysis. Question: calculate the number of moles of oxygen that will react with 8.5 gram of NH3. Balanced chemical reaction is given as 4NH3 plus 5O2 makes 4NO plus 6H2O. It is clear from this equation that 4 moles of ammonia reacts with 5 moles of oxygen gas. Number of moles of ammonia will be equal to 8.5 upon molar mass of ammonia, and that is 17 gram. So number of moles of NH3 will be 8.5 upon 17, that is 0.5. Since 4 moles of ammonia react with 5 moles of oxygen, so 0.5 moles of ammonia will react with 0.5 into 5 upon 4. So that is 2.5 upon 4, and that is equal to 0.625 moles of oxygen, and that is the answer. Now let us see volume analysis. Question: 10 ml of liquid CS2 is burnt in oxygen. Find the volume of the resulting CO2 at STP. Specific gravity of CS2 is 2.63. Balanced chemical equation is given as CS2 plus 3O2 makes CO2 plus 2SO2. That means 1 mole of CS2 produces 1 mole of CO2. Volume of 1 mole of CO2 at STP is 22.4 liter. Molar mass of CS2 is 76 gram. Means 76 gram of CS2 produces 22.4 liter of CO2. We will calculate mass of 10 ml of CS2. So mass of 10 ml of CS2 is equal to volume into specific gravity. Volume is 10 ml into specific gravity is given as 2.63. So mass of 10 ml of CS2 is 26.3 gram. Since 76 gram of SO2 produces 22.4 liter of CO2, so 26.3 gram of SO2 produces how much CO2? It comes out to be 26.3 into 22.4 upon 76, that is 7.75 liter of CO2. Now let us understand the limiting reagent. Many a times in a chemical reaction, the amount of reactants is different from the amount of reactants required in a balanced chemical reaction. In such cases, one reactant gets completely consumed, limiting the amount of product formed. Such a reactant is called as a limiting reagent. Let us see this question. For the reaction x plus 2y makes z, how many moles of z will be produced when 4 moles of x react with 6 moles of y? Also, find out the limiting reagent. It is given as x plus 2y makes z. It means 1 mole of x reacts with 2 moles of y to produce 1 mole of z. So if there are 6 moles of y, they will react with 3 moles of x to produce 3 moles of z. So y gets completely consumed. Still 1 mole of x will be remaining in the reaction. So y is limiting reagent and it will produce 3 moles of z. Now let us understand reactions in solutions. A majority of reactions in laboratories are carried out in solutions. So we need to understand what are solutions and how the concentration of solutions are expressed. A solution is made of two components. One is called solute and another is called solvent. For example, aqueous sugar solution. Sugar is solute and water is solvent. Concentration of solutions are expressed in 5 different ways and they are molarity, molality, mole fraction, percentage calculation and ppm. We will see them one by one. First one is molarity. It is defined as the number of moles of the solute present in 1 liter of the solution. It is represented by capital M. So molarity is equal to number of moles of solute upon volume of the solution in liters. Here 1 liter is equal to 1000 ml. Let us do one numerical based on it. Calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solution. First, we will figure out how many moles of NaOH are there in 4 gram. To do that, we will calculate the molar mass of NaOH and then divide this number by molar mass. So let us do that. Molar mass of NaOH will be 23 into 1 plus 16 into 1 plus 1 into 1, that is 40 gram. So number of moles in 4 gram of NaOH will be 4 upon 40, that will be 0.1 moles. Now we will say since 250 ml of solution contains 0.1 moles of NaOH, so 1000 ml of solution will contain how many moles of NaOH? So that will be 1000 into 0.1 upon 250. That comes out to be 0.4 molar. Second one is molality. It is defined as the number of moles of solute present in 1 kg of solvent. It is denoted by small m. So molality is equal to number of moles of solute upon mass of solvent in kg. We know that 1 kg is 1000 gram. Let us do one numerical based on it. The density of 3 molar solution of NaCl is 1.25 gram per ml. Calculate the molality of the solution. Here NaCl is solute. We want to calculate mass of solvent. So let us do that. 3 molar NaCl means 3 moles of NaCl in 1000 ml of solution. So mass of solution is equal to volume of solution into density of solution. Volume of solution is 1000 ml into density of solution is given as 1.25 gram per ml. So mass of solution comes out to be 1250 gram. Now we will calculate the mass of 3 moles of NaCl, that is solute. So molar mass of NaCl will be 23 into 1 plus 35.5 into 1. That comes out to be 58.5 gram. So mass of 3 moles of NaCl will be 3 into 58.5. That is 175.5 gram. So mass of solvent will be equal to mass of solution minus mass of solute. Mass of solution we have calculated as 1250 gram and mass of solute is 175.5 gram. So mass of solvent will be 1250 minus 175.5. That comes out to be 1074.5 gram. Now we will say, since 1074.5 gram of solvent contains 3 moles of NaCl. So 1000 gram of solvent contains how many moles of NaCl? That comes out to be 2.79 moles of NaCl. And we will say its concentration is 2.79 molar. Third one is mole fraction. It is the ratio of number of moles of a particular component to the total number of moles of the solution. If a substance A dissolves in substance B and their number of moles are Na and Nb respectively, let's say A is solute and B is solvent, then mole fraction of A is equal to Na upon Na plus Nb. That is number of moles of A upon number of moles of the solution. And mole fraction of B is equal to Nb upon Na plus Nb. That is number of moles of B upon number of moles of the solution. Let us do one numerical based on it. Mole fraction of a substance in water is 0.2. Calculate its molality in water. Mole fraction of solute is 0.2. So mole fraction of solvent, that is water, will be 1 minus 0.2, that is 0.8 moles. So molar mass of solvent, that is water, is equal to 1 into 2 plus 16 into 1, that is 18 gram. So mass of 0.8 moles of H2O will be 14.4 gram. Now we will say 14.4 gram of H2O contains 0.2 moles of solute. So 1000 gram of H2O contains, here H2O is solvent. 1000 into 0.2 upon 14.4. That comes out to be 13.89 moles of solute. So its concentration will be 13.89 molar. Fourth one is percentage calculation. It is of 3 types: percentage W by W, percentage W by V, and percentage V by V. Percentage W by W. It is given as the mass of solute present in 100 gram of solution. Percentage W by W is equal to mass of solute in gram upon mass of solution in gram multiplied by 100. It is easy to remember as first W represents mass of solute and second W represents mass of solution. Percentage W by V. It is given as the mass of solute present in 100 ml of solution. Percentage W by V is equal to mass of solute in gram upon volume of solution in ml multiplied by 100. Here W represents mass of solute and V represents volume of solution. Percentage V by V. It is given as the volume of solute present in 100 ml of solution. Percentage V by V is equal to volume of solute in ml upon volume of solution in ml multiplied by 100. Here first V represents volume of solute and second V represents volume of solution. Fifth one is parts per million, known as ppm. It is given by mass upon volume of solute upon mass upon volume of solvent multiplied by 10 to power 6. We will see some numericals based on these formulas. First question, a mixture of ethanol and water contains 46% ethanol by mass. Calculate the mole fraction of water in this solution. 46% ethanol by mass means out of 100 gram of solution, ethanol is 46 gram and water is 100 minus 46, that is 54 gram. Here solute is ethanol and solvent is water. Now we will calculate how many moles of ethanol are there in 46 gram and how many moles of water are there in 54 gram. To do that, we need to calculate their molar masses first. So molar mass of ethanol, that is represented by C2H5OH, is equal to 12 into 2 plus 1 into 5 plus 16 into 1 plus 1 into 1, that is 46 gram. Similarly, molar mass of water H2O is equal to 1 into 2 plus 16 into 1, that comes out to be 18 gram. So number of moles of ethanol is equal to mass of ethanol 46 gram upon its molar mass, that is 46. So 46 upon 46 is 1. And number of moles of water is equal to mass of water upon molar mass of water, that is 54 upon 18, that is 3. So mole fraction of water is equal to number of moles of water upon number of moles of water plus number of moles of ethanol, that is 3 upon 3 plus 1, that is 3 upon 4, and that comes out to be 0.75. Second question, calculate the molarity of the solution containing 5.6% mass volume solution of KOH. 5.6% mass volume solution of KOH means 5.6 gram of KOH in 100 ml solution. First, we will figure out how many moles of KOH are there in 5.6 gram of KOH. Molar mass of KOH is equal to 39 into 1 plus 16 into 1 plus 1 into 1, that is 56 gram. So number of moles of KOH will be 5.6 upon 56, that is 0.1. Now we will say, since 100 ml of solution contains 0.1 moles of KOH, so 1000 ml solution contains how many moles of KOH? That will be 1000 into 0.1 upon 100. That comes out to be 1 mole. So it will be 1 molar solution. Third question, calculate the amount of 90% pure Na2CO3 required to prepare 2 liters of 0.4 m solution. 0.4 m solution means 0.4 moles of Na2CO3 are present in 1 liter solution. So 2 liter solution will contain how many moles of Na2CO3? Double. 2 into 0.4, that is 0.8 moles of Na2CO3. Now we will calculate the mass of 0.8 moles of Na2CO3. Molar mass of Na2CO3 is 23 into 2 plus 12 into 1 plus 16 into 3. That comes out to be 106 gram. So mass of 0.8 moles of Na2CO3 will be 0.8 into molar mass 106, that is 84.8 gram. Now we will say 90 gram of pure Na2CO3 is obtained from 100 gram of sample, as it is 90% pure. So 84.8 gram of pure Na2CO3 is obtained from what amount of sample? That is 84.8 into 100 upon 90. That comes out to be 94.22 gram of sample. There are few topics left out in this chapter. They are significant figures, precision and accuracy, and dimensional analysis. We will cover them towards the end of this course. Today we will solve few questions from previous year's JEE papers. The one and only one trick to solve these questions like a pro is to keep the various terms definitions in your mind. For example, what is mole fraction, molarity, molality, ppm, limiting reagent, molecular formula, empirical formula, etc. So let us start. First question, in an estimation of bromine by gaseous method, 1.6 gram of an organic compound gave 1.88 gram of AgBr. The mass percentage of bromine in the compound is, atomic mass of Ag is 108 and that of bromine is 80 gram per mole. This question appeared in JEE Mains 2020. Suppose X is organic compound. 1.6 gram of X gave 1.88 gram of AgBr. First, we will calculate the molar mass of AgBr. 1 mole of AgBr consists of 1 atom of Ag and 1 atom of Br. So, molar mass will be 108 into 1 plus 80 into 1. That is 188 gram. So, out of 188 gram of AgBr, bromine is 80 gram. So, out of 1.88 gram of AgBr, how much will be the bromine? That will be 0.8 gram. This bromine is coming from X. So 1.6 gram of X contains 0.8 gram of bromine. So 100 gram of X contains how much of bromine? It will come out to be 50. That means mass percentage of bromine in X is 50%. So we will fill 50 here. Second question, the minimum number of moles of O2 required for complete combustion of 1 mole of propane C3H8 and 2 moles of butane C4H10 is. This question appeared in JEE Mains 2020. Combustion means reaction with oxygen. First step is to find out the balanced chemical equation. That comes out to be 2C3H8 plus 10O2 makes 6CO2 plus 8H2O. And 2C4H10 plus 13O2 makes 8CO2 plus 10H2O. Now 2 moles of C3H8 react with 10 moles of O2. We have to find out 1 mole of C3H8 will react with how many moles of O2. So it will be 5 moles of O2. 2 moles of C4H10 reacts with 13 moles of O2. And we have to find out the same 2 moles of butane. So it will be 13 moles of O2. So combining these two, we need minimum number of moles of O2 required will be 5 plus 13. That will be 18. So answer is 18. Third question, complete combustion of 750 gram of an organic compound provides 420 gram of CO2 and 210 gram of H2O. The percentage composition of carbon and hydrogen in organic compound is 15.3 and respectively. Round off to the nearest integer. This question appeared in JEE Mains 2021. Suppose X is organic compound. Combustion means reaction with oxygen. So 750 gram of X gives 420 gram of CO2 and 210 gram of water. First, we will calculate the molar mass of carbon dioxide. So it will be 12 into 1 plus 16 into 2. That will be 44. Similarly, molar mass of H2O will be 18. So out of 44 gram of CO2, carbon is 12 gram. So out of 420 gram, how much will be the carbon? It will be this much. Similarly, out of 18 gram of water, hydrogen is 2 gram. So out of 210 gram of water, how much is the hydrogen? This much. Now both carbon and hydrogen are coming from X. So out of 750 gram, hydrogen is this much. So out of 100, how much will be the hydrogen? It comes out to be 3.11. We have to round off to the nearest integer, so it will be 3. Our answer will be 3% of hydrogen. Fourth question, 1.86 gram of aniline completely reacts to form acetanilide. 10% of the product is lost during purification. Amount of acetanilide obtained after purification in gram is something into 10 to power minus 2. This is the chemical reaction. This question appeared in JEE Mains 2021. From this chemical reaction, it is clear that 1 mole of aniline produces 1 mole of acetanilide if there is no loss of product during purification. Considering the loss during purification, 1 mole of aniline produces only 0.9 moles of acetanilide. So let us figure out how many moles of aniline were there in 1.86 gram. Molar mass of aniline we can calculate as 12 into 6 plus 1 into 5 plus 14 into 1 plus 1 into 2. That comes out to be 93 gram. So number of moles of C6H5NH2, that is aniline, will be 1.86 gram upon molar mass 93. So that comes out to be 0.02. That means initially there were 0.02 moles of aniline. So they will produce 0.02 moles of acetanilide if there is no loss of product. Considering the loss, it will be only 90% of 0.02. That comes out to be 0.018 moles of acetanilide produced. So if we multiply this number with molar mass of acetanilide, we will find the exact amount of acetanilide produced. So molar mass of acetanilide we can calculate as number of carbon atoms in this structure is 6 plus 1 7 plus 1 8. So 12 into 8 plus number of nitrogen atoms 1. So 14 into 1 plus number of oxygen atoms 1. 16 into 1 plus number of hydrogen atoms 5 plus 1 6 plus 3 9. So 1 into 9. That comes out to be 135. That is molar mass of acetanilide. So mass of 0.018 moles of acetanilide will be 0.018 into molar mass 135. So the amount of acetanilide produced will be 2.43 gram. We have to write answer into something into 10 to power minus 2. So we can rewrite this as 243 into 10 to power minus 2 gram. So we will fill 243 in the blank here. Fifth question, the NaNO3 weighed out to make 50 ml of an aqueous solution containing 70 mg Na plus per ml is dash gram. Round off to the nearest integer. Atomic mass in gram per mole, sodium 23, nitrogen 14 and oxygen 16. This question appeared in JEE Mains 2021. So we have to make the aqueous solution of NaNO3. It is given that 1 ml of this solution contains 70 mg of Na plus. So 50 ml of this solution will contain how much of Na plus? It will be 50 into 70 upon 1. That will be 3500 mg of Na plus. That is equivalent to 3.5 gram of Na plus. NaNO3 is made of Na plus and NO3 minus ions. Let us calculate the molar mass of NaNO3, and that will be 23 into 1 plus 14 into 1 plus 16 into 3. That comes out to be 85 gram. 23 gram of Na plus is there in 85 gram of NaNO3. So 3.5 gram of Na plus will be there in how much of NaNO3? It will be 3.5 into 85 upon 23. That comes out to be 12.93 gram of NaNO3. Now we have to round off to the nearest integer. It will be equal to 13 or equivalent to 13 gram of NaNO3. So we will fill 13 here. Sixth question, complete combustion of 3 gram of ethane gives X into 10 to power 22 molecules of water. The value of X is, round off to the nearest integer. Use Na is equal to 6.023 into 10 to power 23. Atomic mass in U, C12, O16 and H1. This question appeared in JEE Mains 2021. Balanced chemical equation is this. 2C2H6, that is ethane, plus 7O2 makes 4CO2 plus 6H2O. It is clear from this equation that 2 moles of C2H6 produce 6 moles of water. So first let us figure out how many moles of C2H6 are there in 3 gram. So molar mass of C2H6 is 12 into 2 plus 1 into 6, that is 30 gram. So number of moles in 3 gram of C2H6 will be 3 upon 30. 3 upon 30. So that will be 0.1 moles. Now 2 moles of C2H6 produce 6 moles of water. So 0.1 moles of C2H6 will produce how many moles of water? It will be 0.1 into 6 upon 2. That is 0.3 moles of water. We know that 1 mole of water contains 6.023 into 10 to power 23 molecules of water. So 0.3 moles of water will contain how many molecules of water? That comes out to be 1.8069 into 10 to power 23. We have to write the answer as X into 10 to power 22. So we will convert it to 10 to power 22. So it will be 18.069 into 10 to power 22. Now we have to round it off to nearest integer. So it will be 18 into 10 to power 22. Now compare this with this, x comes out to be 18. That is our answer. Seventh question, this is the reaction. Consider the above reaction where 6.1 gram of benzoic acid is used to get 7.8 gram of M-bromo-benzoic acid. The percentage yield of the product is, round off to the nearest integer, given atomic mass in U C12H1O69Br80. This question appeared in JEE Mains 2021. So this is the chemical reaction given. This is benzene ring. It is represented by C6H6. Since COOH is attached with it, that means we have to take one H out. So its formula can be written as C6H5COOH. Similarly, this is benzene ring, one Br and one COH is attached. So we have to take two H out, and in place of both H, we have to write one Br and one COH. So its formula will be C6H4BrCOH. So now this will be the chemical reaction. It is clear from this chemical reaction that 1 mole of benzoic acid will produce 1 mole of M-bromo-benzoic acid. So first we will figure out how many moles are there in 6.1 gram of benzoic acid. So molar mass of C6H5COH will be 12 into 6 plus 1 into 5 plus 12 into 1 plus 16 into 2 plus 1 into 1. That will be 122 gram. So number of moles of benzoic acid will be 6.1 upon 122. That will be 1.20 or 0.05 moles. So 0.05 moles should produce 0.05 moles of M-bromo-benzoic acid. So let us calculate the molar mass of M-bromo-benzoic acid, and that will be equal to 12 into 6 plus 1 into 4 plus 80 into 1 plus 12 into 1 plus 16 into 2 plus 1 into 1, and that will come out to be 201 gram. So mass of 0.05 moles of M-bromo-benzoic acid should be 10.05 gram, and you see only 7.8 gram is produced. So we will say out of 10.05 gram, only 7.8 gram is produced. So out of 100 gram, how much will be produced? It will be 77.61, and that is percentage. Now we have to round off to the nearest integer. It will be 78%. So we will write 78 here. Eighth question, a 6.5 molar solution of KOH aqueous has a density of 1.89 gram per centimeter cube. The molarity of the solution is mole per decimeter cube. Round off to the nearest integer. Atomic mass in U K39O69H1. This question appeared in JEE Mains 2021. In solution, KOH is solute and H2O is solvent. And we know that solute plus solvent is equal to solution. So 6.5 molar means 6.5 moles of solute KOH in 1000 gram of solvent H2O. Let us figure out how much is the mass of 6.5 moles of KOH. So first we will calculate the molar mass of KOH. So molar mass of KOH will be 39 into 1 plus 16 into 1 plus 1 into 1. That is 56 gram. So mass of 6.5 moles of KOH will be 6.5 into 56, that is 364 gram. So in solution, mass of solute is 364 gram and mass of solvent is 1000 gram. So total mass of the solution means solute plus solvent will be 364 plus 1000, that is 1364 gram. So volume of the solution will be mass of solution upon density of solution. Mass of solution we have just figured out 1364 gram, and density of the solution is given as 1.89 gram per centimeter cube. So volume of the solution will be 1364 upon 1.89 centimeter cube. So molarity of the solution will be given by moles of solute upon volume of solution. Moles of solute we already know 6.5 moles of KOH. Upon volume of the solution we have just figured out 1364 upon 1.89. So it will come out to be 0.0090 moles per centimeter cube. and we have to write the answer in mole per decimeter cube. Means we have to multiply this by 10 to power 3. So it will come out to be 9 moles per decimeter cube. So our answer will be 9 moles per decimeter. Ninth question, for a reaction N2 plus 3H2 makes 2NH3, identify dihydrogen H2 as a limiting reagent in the following reaction mixtures. These are the options given. This question appeared in JEE Mains 2019. It is clear from this equation that in order for H2 and N2 to get completely consumed in the reaction, the molar ratio of H2 is to N2 should be 3:1. For H2 to be limiting reagent, number of moles of N2 should be more than 1 when number of moles of H2 are 3. So let us see out of these options in which option number of moles of N2 is more than 1 when number of moles of H2 is 3. First option, moles of N2 will be 14 by 28, that is 0.5, and moles of H2 will be 4 by 2, that is 2. So N2 is to H2 will be 0.5 is to 2, that is 0.75 is to 3. So that is not the correct option because N2 should be more than 1. Second option, moles of N2 is 28 by 28, that is 1, and moles of H2 will be 6 by 2, that is 3. So N2 is to H2 will be 1 is to 3. That also is not the correct option because N2 should be more than 1. Third option, moles of N2 will be 56 by 28, that is 2, and moles of H2 will be 10 upon 2, that is 5. So N2 is to H2 is 2:5 or 1.2 is to 3. So this is the correct option. Let us see option 4 also. Moles of N2 is equal to 35 by 28, that is 1.25, and moles of H2 is equal to 8 by 2, that is 4. So N2 is to H2 is 1.25 is to 4, that is 0.94 is to 3. That also is wrong option because N2 should be more than 1. So our correct option is option 3. 10th question, 6.023 into 10 to power 22 molecules are present in 10 gram of a substance X. The molarity of a solution containing 5 gram of substance X in 2 liter solution is dash into 10 to power minus 3. This question appeared in JEE Mains 2020. We will form our logic as 6.023 into 10 to power 22 molecules are present in 10 gram of substance X. So Avogadro number means 6.023 into 10 to power 23 molecules are present in what amount of substance? That comes out to be 100 gram. So 100 gram is molar mass of substance X. Now we will figure out how many moles are there in 5 gram of substance. That will be 5 upon molar mass 100, that is 1 by 20. So 1 by 20 moles are present in 2 liter of solution. So we will form our logic again as 2 liter solution contains 1 by 20 moles of X. So 1 liter solution will contain how many moles of X? That is 1 upon 20 into 2 in denominator, that is 1 by 40 or 0.025 moles per liter, or we can write as 25 into 10 to power minus 3. So in this space 25 will come. 11th question, aluminium reacts with sulfuric acid to form aluminium sulfate and hydrogen. What is the volume of hydrogen gas in liters produced at 300 Kelvin and 1 atmospheric pressure when 5.4 gram of aluminium and 50 ml of 5 molar sulfuric acid are combined for the reaction? Use molar mass of aluminium is equal to 27 gram per mole, R is equal to 0.082 atmospheric liter per mole per Kelvin. This question was asked in JEE Advanced 2020. Balanced chemical equation will be like this. 2Al plus 3H2SO4 makes Al2SO4 thrice plus 3H2. It is given that 5.4 gram of aluminium is combining with 50 ml of 5 molar H2SO4 solution. Now we will figure out whether they are combining in 2:3 molar ratio or not. If they are combining in 2:3 molar ratio, that means they will be completely consumed in the reaction. Otherwise, one will be limiting reagent. Let us find out the number of moles of aluminium and H2SO4 first. So number of moles of aluminium will be 5.4 gram upon molar mass of aluminium, that is 27. So it will be 0.2. Number of moles of H2SO4 can be calculated as, it is given that 1000 ml of solution contains 5 moles of H2SO4. That is the meaning of 5 molar sulfuric acid. So 50 ml of solution contains how many moles of H2SO4? That comes out to be 0.25 moles of H2SO4. So the molar ratio of aluminium and H2SO4 is 0.2:0.25. Multiply both by 10. So equivalent ratio will be 2:2.5. What it means is 2 moles of aluminium need 3 moles of H2SO4 to completely combine. But only 2.5 moles of H2SO4 are available. So H2SO4 is short, means H2SO4 is limiting reagent. So our further calculation will be based on limiting reagent. Now we will say that 3 moles of H2SO4 produce 3 moles of hydrogen gas. So 0.25 moles of H2SO4 will produce 0.25 moles of H2 gas. So our N is equal to 0.25. For ideal gas, PV is equal to nRT, where N is number of moles of gas. So V is equal to nRT upon P. N is 0.25, R is given as 0.082, T is given as 300 Kelvin, and P is given as 1 atmospheric pressure. So V comes out to be 6.15 liter. That is volume of hydrogen gas produced. Last question. The mole fraction of urea in an aqueous urea solution containing 900 gram of water is 0.05. If the density of the solution is 1.2 gram per centimeter cube, the molarity of urea solution is. Molar mass of urea and water are 60 gram per mole and 18 gram per mole respectively. This question appeared in JEE Advanced 2019. In urea solution, urea is solute and water is solvent. First, we will figure out how many moles of water are there in 900 gram of water. Molar mass of water is 1 into 2 plus 16 into 1, that is 18 gram. So number of moles of water in 900 gram is 900 upon 18, that is 50 moles. So there are 50 moles of solvent water. Now mole fraction of urea is equal to number of moles of urea upon number of moles of urea plus number of moles of water. Let's say number of moles of urea is represented by Na. So mole fraction of urea is given as 0.05. So 0.05 is equal to Na upon Na plus 50. So Na comes out to be 2.5 upon 0.95. Now we will calculate the mass of these many moles of solute. So mass of 2.5 upon 0.95 moles of urea is equal to 2.5 upon 0.95 into molar mass of urea, that is given as 60 gram per mole. So mass of these many moles of urea will be 3000 upon 19 gram. Now total mass of solute plus solvent will be mass of solute plus mass of solvent, and that comes out to be 20100 upon 19 gram of solution, because solution is mass of solute plus mass of solvent. Now we will calculate volume of the solution. So volume of the solution is equal to mass of solution upon density of solution. Mass of solution is this and density is given as 1.2 gram per centimeter cube. So volume of solution is these many mLs. Now we will say when this is volume of the solution, these many mLs, number of moles of solute are these many. So if solution is 1000 ml, then how many moles of solute will be there? This comes out to be 2.99 moles, and the solution is now 2.99 molar solution. In next video, we will start second chapter, that is structure of atom. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.